Today we're taking a look at some different ropes and even webbing. We're going to go into the different types that are out there on the market and when you should be using each one. Before we get started, I do want to say that this information in this video is for educational purposes only. This is not a replacement for any in-person class, and you shouldn't take just this information and go perform rescues or use these skills in a dangerous environment. You should always get proper in-person training. So this is the first video of several in a series related to using ropes for rescue. There's a lot of different things that we can use ropes for, but I have a feeling that most of the time we are used to using some of that cheap rope from the hardware store, or maybe even some paracord if you're tactical, for tying things down in the back of our truck. But there are lots of different types of ropes out there, a lot of uses for them, and I often hear that when someone has to tie something down or start tying knots, they usually defer to the person in the group that's the Boy Scout because they're supposed to know how to tie knots. Well, we're about to teach you about different types of ropes, different knots that you can use in different circumstances, and then ultimately how this applies to you being a prepared civilian, being ready to respond, to be able to help other people that are in need. So before we get too far into how to use some of these things and techniques that we're going to use, we have to start with the basics. We have to understand our equipment. So today we're going over different types of rope and webbing. We are talking about the different materials, the different use cases, and hopefully this gives you a better understanding of what rope you need to buy for your specific use case. So I'm sure that you're familiar with ropes to some level. You've probably used one of those old natural fiber ropes that your dad had in his truck. You used it to tie down some garbage to take to the dump, or maybe you've even gotten a little more sophisticated and you've actually used some kernmantle rope in specific situations, whether it's rock climbing or rescue, or maybe it's even just recreational repelling at an adventure park. But when we're talking about using a rope for a specific use case, we have to match up the materials, the size, the weight ratings, and everything for this use case so that we can perform these functions safely and we don't have any catastrophic failures in our rope. Let's take a look at some of the materials that they make rope out of. Some of the old style of rope were made from natural fibers. So a problem with natural fiber ropes is they will degrade quickly in the sun. They're very susceptible to rot, so if they get wet and don't dry out fully, they will actually start to rot, kind of like natural products do in a compost pile. So while they were a great first generation of ropes and had a lot of uses and really allowed people to be able to tie things together before the invention of a lot of synthetic ropes, they really aren't a good option for much today, except that they may be a cheaper option if you just need some disposable twine to be able to tie some things down that's not very important. So two of the more common materials found in ropes these days would be nylon and polyester. We also have polypropylene that's used when we need that rope to be able to float because it is much lighter and floats on top of water, but it's not as strong. We've also lately seen a lot of aramid type fibers like Technura or Kevlar or some of these heavy duty fibers that are more fire resistant, less susceptible to heat, so you can repel faster on them. You can use them for fire rescue where they're going to be in hot environments and they won't melt. And we've seen a lot of those come into the market more recently. The downside of those specific fibers is that they are more expensive, even though they are a lot of times stronger, less susceptible to UV damage, and a lot of times a better rope for a lot of these applications. So let's talk for a minute about polyester and nylon. So I have here a rescue rope. This is a kernmantle rope, which we'll talk about in a minute, but it has two different types of materials. It has a nylon core with a polyester sheath around the outside. Polyester is very common in rescue ropes and also dynamic ropes used for rock climbing. So polyester is a synthetic rope material. It's cheap and readily available, and that is what they use a lot of times in a lot of these recreational or rescue rated ropes. It also retains its strength even when it gets wet. So for rescue purposes, when this rope gets wet, we don't lose a lot of strength in it, which is good because we don't usually get to pick the weather that's at hand when we're performing rescues. So I mentioned that the core of this is actually nylon. Nylon is used in rope along with webbing. Most flat webbing is made from nylon. Now here's a fact about nylon. It actually decreases in strength when it gets wet. So that's a downside to nylon, and it's also a little bit more expensive. Now it is stronger than polyester as long as it stays dry, but it decreases in strength when it gets wet, so that's one reason that it's not as popular. Now, if we are trying to make a rope smaller and actually retain a lot of the strength that a polyester rope would have, when we make it smaller, we may have to change some of those components over to a nylon, which is what they have done here in this rope. So this is an 11mm rescue rope. Like I said, it has a nylon core, polyester sheath, and it's rated at 9,000 pounds minimum breaking strength. This is a smaller type of kernmantle rope, very similar to the one I just showed you. The size is a little bit smaller, it's 8mm, but this is polyester on polyester. So the core is polyester and the sheath is polyester, which is probably your most common for a lot of your static and dynamic ropes you find out there. This is a throw bag. This is used for water rescue. It has a rope inside this bag. You can throw the bag. As you throw the bag, this rope deploys out of the bag, so you can throw a line to someone that's floating away. They can grab the line, you can pull them over to shore or to a safe place. This, because it's used for the water, doesn't have to be as strong because we're not hanging heavy weights off of it, but we do want it to float so that we can see the line. So it's a bright color, but this is made out of polypropylene, which floats on water. Polypropylene is also fairly economical, but the downside is it's not as strong as polyester or nylon. So we can use this when we need it for water. We just know that it's not going to be as strong as our other ropes. So a lot of the latest generation of ropes are being made out of these aramid fibers like Technora or Spectra or Dyneema, or some of these cut resistant, high temperature resistant ropes. This right here is a tactical rope. It's meant for canyoneering or for rope access. Tactical world, you can use this in high temperature environments. It has a melting point of somewhere around 2,000 degrees, I believe. It has a minimum breaking strength of 5,400 pounds, but this comes in a smaller diameter of 8mm. So this is a much smaller rope than some of the rescue ropes I showed you before. It's really strong, it's cut resistant, abrasion resistant because of that, but this smaller rope is actually much more expensive than some of the other options you've seen so far, simply because it has some of these higher dollar fibers in it. And just for show and tell, I have this small amount of Technora 1200 fiber here. It has a breaking strength of 1,200 pounds in this tiny little rope. This is just a braided rope, so there's no core to it, but this fiber is really strong. And a downside to some of these aramid fibers, like Technora, is when you go to cut it, you can't just cut it with a hot knife because it doesn't just melt. You can't burn the ends together because, again, it doesn't melt. So you have to have the right tools to be able to cut this, to be able to get through it. And you need to make sure that you bind the ends well, because if you don't, these are very prone to coming apart and making a mess. And again, you can't just melt them with a lighter. So it's a little bit more difficult to work with, but if you get a set piece of a certain length from the manufacturer and they bind the ends properly, you shouldn't have any issues. All right, before we go any further, if you find any of this information helpful that we're going over today, we'd really appreciate if you give this video a like. That would help us out a lot. If you have questions over some of the stuff that we're talking about today, leave us a comment down below. We'd love to hear from you, and we'll try to get back to you as soon as we can. If you're not already subscribed to the channel, hit the subscribe button and make sure your notifications are on so you'll be alerted when we release future videos. So let's talk for a minute about how some of these ropes are made. So a typical rope that you may get from the hardware store may be either just a simple braided rope, or it could be a twisted rope or a laid rope. So basically they take a bunch of coils, it's coiled around itself. You notice that if they start coming undone, it looks like a bunch of curly hair or something, just because it's these tight coils wrapped around itself. This is common in cheaper ropes, but I don't recommend these for any type of rescue work, and a lot of times they're not even that great for being able to tie down trash in the back of your truck. Typically, when you get into stronger ropes, you want two separate ropes. You want a sheath and a core that are separate. The core will take the majority of the weight, and the sheath is a protective layer that if it gets abrasions or gets cut or something, it will, while it takes some of the weight, if we cut through that, it's not the end of the world, because we still have that core that's been protected, and the structural integrity has not been compromised because that core is still strong and it hasn't been abraded yet. So here I have this white rope here is actually a braid on braid, so it's braided in the middle, and then the core is also braided as well. It's not as common for rescue or rock climbing, but it is one option you can find out there on the market. The most common type of rope construction for rescue and rock climbing is called kernmantle. Kernmantle just means that we have a kern or a core, and then we have a mantle or a sheath that goes over that. So we get about 80% of the strength of the rope in the core, and then the sheath carries about 20%, but mainly is acting as a protective layer so that when our rope starts to get fuzzy and abraded, we're not worried about the structural integrity of the rope as much because we know that that core is still solid inside. So let's talk for a minute about sizes of ropes and what size rope you may need. Now, when we look at ropes, a lot of times these ropes come with what's called a minimum breaking strength. And that minimum breaking strength is either in pounds or kilonewtons. Kilonewtons is roughly 225 pounds of force. So a pound of force is how much force in pounds can be applied. So it's not necessarily a weight, although it can sometimes correlate to a weight, but it's really the force that's applied. So if you don't know how to convert kilonewtons, most of the time these rope manufacturers will put it in pounds as well. Now, typically, the smaller the rope, the less weight it can hold. But a lot of that has to do with the construction of the rope and the material used in that rope. So for example here, I have some Prusiks, which are basically just accessory cord that are tied into loops. These are 8 millimeter, and these are typical accessory cordage for a 1/2 inch or 13 millimeter rescue rope. So this would be used as accessory cordage and not specifically for a main line when we're doing any type of rescue work. This does, however, work as a bailout line or a single person line if we need to do a quick rappel, or you just need some cord in your vehicle or in your kit that allows you to be able to do an emergency bailout or be able to hold the weight of one person, but we're not necessarily putting 2 people on this repeatedly. In the fire and rescue world, we've for a long time used 1/2 inch rope. It's way more overkill than what we really need for the rescue we're doing, but if we have a big red fire truck that has tons of room on it and we can put these massive ropes in there, then the thought was, why not? Let's just have a big overdone rope. If it gets abraded or cut or whatever, we're still way above where we need to be for a safety margin. The problem is it does get cumbersome, it gets hard to tie knots, the ropes are more expensive, and there are some downsides to having these big bulky ropes. If you talk to someone in the caving industry, they're using much lighter ropes, much smaller ropes. Some of these aramid fibers, Technora, and even some polyester ropes that are much smaller in size. So these 1/2 inch ropes that they've been using in the fire service are somewhere between 12 millimeter and 13 millimeter. So we typically just say 13 millimeter ropes when we're referring to these 1/2 inch ropes. There's been a common move in the fire service to be able to move down toward an 11 millimeter rope. Some fire departments are doing it and just understanding the risk with less safety margin, moving from 9,000 pounds down to 7,200 to 7,600 pounds on that rope. But there are also some manufacturers that are making ropes that are 11 millimeter, such as this one right here by CMC, and this is rated at 9,000 pounds, even though it's an 11 millimeter rope. Either way, 11 millimeter has become the recent standard for professional fire and rescue, but a lot of the guys in technical rescue on the caving and outdoor canyoneering side of things may still be using something more like a 9 millimeter, but again, they're probably using Technora or some of these other more expensive ropes. This rope that I have in my throw bag for water rescue is a 3/8 inch rope, and it has a breaking strength or a maximum strength of 1,800 pounds, which is significantly less than these other ropes. But again, it floats on water, and I'm not suspending heavy loads hanging vertically off of it. We're using it to float on water that someone can hang on to it, and we can vector them over to the shore for a rescue. I also have a large 5/8 rope here. This is just a massive rope. I really don't plan to use it for anything. I'm not even sure why I have it, but this is really strong, but the downside is because it's so big, it's hard to tie knots out of, and it's really just impractical to use for a lot of things. And most of the hardware, pulleys, carabiners, that type of stuff I have, it's not going to be very compatible with. So yeah, I don't really recommend getting this unless you have a very specific reason to have it. One other thing I should mention with ropes, when you buy a rope, you can buy a static or dynamic rope. There are also, in the category of static ropes, there's also some no stretch, some low stretch, and so all this has to do with how elastic these ropes are. If you're a rock climber, you want a dynamic rope. When you're climbing up, clipping into this rope, and you were to slip and fall, you want some stretch in that rope. If you don't have stretch in that rope, then you don't have a rope that's slowly taking your fall, kind of like a bungee cord does. Instead, your weight would hit all at once. You would put a lot of weight on your anchors that you have set, and you'd also shock load your rope, decreasing the strength of the rope if you do that over and over again. And it's much harder on you, so you don't have as much shock absorption when you fall, and also the person that's belaying you. So for that reason, climbers specifically want a stretchable dynamic rope. If you are hoisting loads, moving loads, or even repelling, you want a static line or a low stretch line. If you have a line that doesn't stretch at all, it's more susceptible to shock loading your rope and your anchor and potentially producing a failure in that quicker than one that would stretch and give a little bit, acting as a shock absorber. So true static lines are not very common. Most of the time, people will have a low stretch rope that has a little bit of elongation when you have weight on it, but not much. Think of trying to rescue a patient and you're hanging off this system, and now you're gonna put a second person on your system. Now, once you take their weight on your system, you're gonna stretch even further, which now moves you past the point of where you're supposed to be. So there's gonna be a lot of movement if we're using a dynamic rope for rescue. So for that reason, we want a low stretch rope for rescue purposes. So if you want an economical, good all-around rope, I would recommend getting a either 8 or 9 millimeter if you want it for a single person, or an 11 millimeter if you want this for a 2-person load like a rescue. Buy this from a reputable company like Teufelberger, Sterling Ropes, CMC. Make sure you're getting a polyester on polyester, kernmantle, static or low stretch rope. A lot of times you'll even see these ropes have NFPA T or NFPA G certifications attached to them. So you know that they are certified to be able to be used in a technical rescue capability. One last thing before we conclude, I do want to hit on webbing. We've done some videos on webbing before, so I'll make this quick. Well, we have a couple different options for webbing. Most of the time it's going to be made out of nylon. When we look at webbing, we can either have flat or tubular webbing. If we're using this for rescue, I would recommend having tubular webbing because we have more strength in this tubular webbing. This looks like flat webbing, but you'll notice that it's actually a tube and it's hollow inside. Rescue rated 1-inch wide webbing has a breaking strength of 4,000 pounds. So it's not as much as our 9,000 pounds for our rescue rated rope, but we can simply double this up and now we're at 8,000, which is much closer to that breaking strength. So our system is going to be pretty equivalent. You can also buy this in 2-inch wide, 1/2-inch wide, but as a basic starting point, I would recommend 1-inch webbing, tubular webbing. This stuff is fairly cheap and economical, and there's a lot of uses for this. One other thing to pay attention to, there are 2 different ways to make webbing. One is to do a continuous weave all the way around. The other is to basically make a 2-inch piece of webbing, fold it, and then stitch one side. Some of the older manufacturers and older styles of webbing, when they stitched it, it'd be a running stitch all the way down the webbing. If you severed or cut that stitch at any point, the rest of the webbing could come unraveled. So I would make sure you're buying from a reputable source such as Bluewater webbing or Sterling or CMC or some of those main companies because they will have that locking stitch in there. So if it gets severed, then you won't have to worry about the rest of this seam coming undone. We also have webbing available on our website, so you can check that out there through 6ecosystems.com. Well, that concludes our introductory video over ropes, talking about the different types of ropes. Hope you found something helpful out of this. Again, if you want a standard rope to be able to keep in your kit, 8 to 9 millimeter or 11 millimeter, whether you want 1 person or 2 person, polyester on polyester, kernmantle from a reputable manufacturer, and you want a static rope for being able to rappel and move loads. So hope this information was helpful, and as always, stay vigilant and stay safe.